Hello and good evening, CSI-158, Section 844 students for the second 8-week term in the fall 2014 semester at Anne Arundel Community College. Today's video tutorial is going to be on OSPF. This is a continuation, sort of part 2 of the OSPFv2 configuration that we did earlier, and this is going to also mirror sort of the lecture that we had on Saturday. And so the first video that was done up was covering OSPFv2. This is going to cover OSPFv3 with IPv6. And as you can see, we have a what should be at this point a very familiar topology. This was the exact same topology that we used for our OSPFv2 with IPv4 configuration and setup. And so we're going to use this exact same topology with our IPv6 setup. All right, so some of the things that we need to remember is that we're going to do IPv6 only here, no IPv4, so it will not be dual stack. And remember that dual stack is defined when you're running both IPv4 and IPv6 on the same topology. So we're going to go ahead and enter no here on routers 4, 5, and 6. And again, we're going to start these routers. These are actually physical real Cisco 1841 ISR Generation 1 or ISR G1 1841 routers. And as you can see here, I've got 2 with the 15.3 branch of code, router 6 and router 4. And then over here, router 5 is running the 12.4 branch of code. All right, so we're going to go ahead and go from from user exec into privilege exec, and then into global config mode. And the first thing that we're going to want to do is we want to set the host name. Now it says it in the tab up above, but we want to make sure that while we're configuring the router here in the command line, we don't have to constantly look up to see which router we're on. All right, so the next thing that we're going to do, and this is a little different than IPv4, and this is one of the differences when you're using IPv6, is we actually have to tell the router to enable IPv6. And so from global config mode, we do IPv6 unicast routing. And so this will turn on the IPv6 routing process, which will allow us to use IPv6 routing. All right, so let's go ahead and let's get our interfaces configured. So as you can see, we're going to configure FA00, and very similar to the IPv4 when we would type IP address. So here, as well as the majority of the commands, we're simply going to be typing IPv6, and as you can see, there's quite a few choices here. So IPv6 address, and we have the LinkLocal address, which is listed in the diagram. And if we look right here, you can see we have our LinkLocal address, FE80::4, and on this side it'll be FE80::6. We also have the global unicast address. So this is our global unicast address, right? So, and this is the subnet we're going to be using here, and so we'll do the same thing we did with the IPv4. So this guy would be, router 6 will be 2001:db8:CAD:46:6/64, and then router 4 would be just :4///4/64. So one of the important things to remember with IPv6 is that while the interface does not need to have a global unicast address, it must have, if it's using IPv6, it has to have the LinkLocal address. So let's go ahead and let's prove that right now. So we'll say IPv6 address FE80::4. Now you'll notice that when I use the FE80::4, I don't put a prefix length at the end of the address. I simply put the address there, and then I'm going to identify it as a link local address, right? And so we've assigned that. So if I do a do show run, and whoops, I'll do a do show run int fa00, and you can see right here that we have our link local address. Now, we've manually configured the link local address here. If I would not have configured the link local address manually, it would have automatically been assigned when I would have assigned a global unicast address. And so we're going to take a look at that on router 6 when we go to configure router 6. So we're going to say no shut because we want to make sure that we bring the interface up. And then let's go ahead and put the global unicast address on here. So we'll say IPv6 address, and if I do a question mark, you can see where if you leave off the / with the prefix length, it's going to assume you're going to be doing a link local, but you still need to put link local at the end of that address. All right, so we're going to say IPv6 address, and we're going to use 2001:db8 ACAD 46 is our subnet. Oops, colon, and we're going to say 4/64, and if I do a question mark at the end, we're not doing any CGA. We're not using, this isn't for the EUI64, which we will see in terms of how that link local address would get selected if we didn't specify what it should be. And so we'll say enter, right? So now if I do a do show run interface fa00, we should see that the interface now has multiple IPv6 addresses assigned to the interface. And this is okay, right? You can have multiple IPv6 addresses assigned to the interface. All right, so now we're going to move over to serial 010, and we're going to do the same thing. We're going to say no shut, and I'm going to assign the IPv6 address. So we'll say IPv6 address fe80::4, and this is interesting here because we've now assigned the same link local address to two different interfaces on the router. And the reason that we can do that is because the link local addresses, if you look here, you can see we've put fe80::4 on that interface, and we've also put fe80::4 on that interface. And you can do that because link local addresses are locally significant to the link on which they reside. So if I had another interface here, let's say this went out to, the internet possibly, I could also use fe80, and that is an E, fe80::4. And if I had an interface that went out to another router, router 3030, I could also use fe80::4. So again, with the link local addresses, they're locally significant. Where I can't use fe80::4 again would be on the other side of this connection, because this is the same link, right? So on either side of the link, I need to make sure that the link locals are unique. However, on the same router, you can have link local addresses on the router interfaces if this router had 4 interfaces, and those link local addresses could be the same for every single link, right? Okay, so that's the key with the link local addresses. And let me go ahead and we're going to assign the IPv6 address for 2001:db8:ACAD:45 for our subnet ::4/64, right? And so there is our IPv6 address setup for serial 010. So if I do a do show run interface serial 010, you can see that the interface is up and we have both IP addresses assigned. All right, so now that that's done, let's go ahead and step over to router 5. And here's where we're actually going to be able to sort of test our connectivity to make sure everything works. So we went from user exec to privilege exec. Now we'll go into global config. We want to set our host name right away so we know which router that we're on. And then I'm going to go ahead, I'm going to go and interface serial 010 on router 5. From here, we'll say no shut to bring the interface up, and I'm going to put just the link local address on here. So if I say IPv6, IPv6 address FE80::5, and then link local, because I want to specify that this is my link local address. We now have a link local address itself. If I do a do show IP interface brief, what would you think we're going to see? If you said we're going to see the IPv4 information, you're correct. So remember, for IPv6, we want to do show IPv6 interface brief. And here is the IPv6 information. So the state of the interface, right, it shows the layer 1 and layer 2 status. However, we want to see that layer 3 status, right? So we need to make sure we identify IPv6. It shows the interface is up and up. And there is our link local address. So now, what happens if I type in do ping FE80::4? All right, so this is very interesting. It's asking me for the output interface. So why do you think it would be asking for the output interface? If you remember back to what we spoke about here on router 4 and the fact that all 4 of those interfaces could have the same link local IP address, if I'm on router 5 and I'm trying to ping to the other side here, I need to tell router 5 which interface to go out, because it could go out this interface, it could go out this interface. If we had another interface here, if this went out to the internet for whatever reason, and that was FE80::5. So this is where we have to tell the ping command which interface I want it to go out. So let's see if I say serial 010. So it says invalid, use full interface name without spaces. So let's try it again. So if I said serial 010. All right, there we go. So again, let's make sure when I type ping, if I say S010, it tells me it's invalid. It wants that full interface name. So if I spell it out, serial 010, it works. So keep that in mind when you're testing your connectivity. So as we can see, I can test, I can ping across to the other side, everything works great. So let me go ahead and assign my global Unicast IP here. So we're going to say IPv6 address 2001:DB8:ACAD:45:5/64. All right, so let's test a ping here. Let's try to ping over to ::4 and see what happens. All right, now you'll notice it did not ask me out which interface I wanted to ping that link local address. And that's because with the global Unicast addresses, now remember, these are different, right? So this here is a global Unicast address, not a link local address. The link local addresses are from FE80::/10. So if I were to say, you know, the range would be in the FE80::/10 subnet range, or I shouldn't say subnet, prefix length of 10. So this is where my link local addresses will reside. So FE80 is what we're using here. So this is a global Unicast address. So this does, on the same router, this does need to be unique. So I couldn't assign this global Unicast address over to the FA00 interface. That's where we would get an error message. And so I'll even try that here in just a second, see what we get. All right. So we've got that interface up. I can ping across both sides. So now let's go to interface FA00. So we'll say no shut, IPv6 address, FE80::5. Whoops. And we're going to make that the link local address. And then now let's see what happens if I tried to assign the same address that I have assigned already to interface serial 010. So let's copy this, because we've already seen that we can do link local addresses, and that those addresses, it's okay to reuse the same link local address. But what happens if I try to assign that address? And so here we get an error. So fast Ethernet 00 error says the address is in use on serial 001. So did it assign it on here and just throw up an error? So let's do show run interface FA00. It did not. So we need to make sure that we get the right IP address on here. So let's recall that command, because I think it's going to be pretty close to what we're looking for. And we'll say 2001 DB8 ACAD 56::5/64. All right, so there we go. And then we'll float over here to router 6. And so on router 6, we'll go from user exec to privilege exec into global config mode, and we'll set our host name to R6. And now we're going to go ahead and configure the interfaces on router 6. So the first interface will be FA01, and we'll say no shut. IPv6 address is going to be FE80::6. Whoop, I keep forgetting my link local, and then IPv6 address 2001:DB8: where we got ACAD: 46::6/64. All right, and so I'm going to make sure I remember here on FA00, we're going to assign the global unicast address first. Remember that you can have on your interfaces, if you're doing IPv6, you must have a link local address. And whether you assign it, as we've done here manually, or it's automatically calculated using the EUI64 method, which we'll see, you must have the link local address. Global unicast address, that is optional. You don't need to have the global unicast address assigned unless you need it or you want it. All right, so let's do a do show run interface on FA01. As we can see there, we've got our link local, so I should be able to ping over to FE80::4. And again, it's going to ask for the interface. So let's say if I do fast Ethernet 01, does it like that? It does not. Whoops. Fast Ethernet 0/1. It wants you to spell it out. And so that is a little bit of a hassle. But again, we need to make sure that we identify the outgoing interface when we're using those link local addresses in the ping commands. For the global unicast address, we don't have to, remember? So if I do ping 2001:DB8:ACAD:46::4, I don't have to, because again, that prefix length and that address, if I do a do show IPv6 route, is going to be is going to be directly connected. And you can see there it is right there. So we have an entry for this in the routing table. It's directly connected. You'll notice that for the FF, well, we'll come back to the FF actually. We'll come back to that. So again, ND is for your neighbor discovery, right? And there is my FE80::4. And this is a neighbor that I've discovered with ICMPv6. And we'll talk a little bit about the neighbor discovery, neighbor solicitation, neighbor advertisement when we get to the ACLs, which is going to be next. All right, so we've got connectivity there. So now let's go on to FA00. And so here in this interface, we're going to say no shut. And I'm also going to go ahead and do the IPv6 global unicast address first. So 2001:DB8:ACAD:56::6/64. Now you'll notice I've only configured the global unicast address here. So if I do a do show IPv6 interface brief, what do we see for fast Ethernet 00? It's in an up and up state. However, I've already been assigned a link local address, which is FE80::224:97 Fox FE8 or FE80, FE27 colon C43A. So now this is going to be a little more difficult to remember than when I'm actually configuring those manually. And again, adding some logic in, saying that my link local address on this link on this, or at least on this side of the link, is simply going to be FE80 colon colon, and then the router number is being used for the last hextet, right? And so this is what's called the EUI64 assignment method for the IPv6 addresses. And so how did we end up with this address? Well, if I do a do show interface on FA00, you'll see that these should look very, very familiar to you, right? So this is the hardware address, and the BIA stands for burned in address. And you can see that we've got 0024, right? So there's a 224, and then 97, and then 27 over here on the other side, but we've inserted the FFFE in there, and then we have the C43A, which again is the last hextet in this address. So how did we end up here? Well, let's go ahead. I'm going to slide this over here so we can still see that information. And so the EUI64 method is pretty straightforward, right? So EUI64, and again, if you don't assign manually the link local address, this is how the link local address will be calculated. So we take the MAC address, which is going to be 00, and I'll draw it in this format here, 00 colon 24, and you get these 48 bits down here, colon 97 colon 27 colon Charlie 4 colon 3 alpha. Let me make sure I've got that. Charlie 4 3 alpha 27 97. All right, so here's what happens with the MAC address. And this is how the EUI64 is going to, because again, remember, MAC addresses, even though they're 48 bits, are supposed to be globally unique. So by using the MAC address to calculate the IPv6 link local address, we should never have an instance where we have two IPv6 link local addresses that are the same. So here's the first thing that takes place. We need to find the 7th bit, right? So these are hexadecimal characters here. So we know that each of these represents 4 binary digits. So we have 0 and 0. Well, we know that 0 is simply 0, 0, 0, 0, and then 0, 0, 0, 0, whoops, 0, 0, 0, 0. So where is our 7th bit? So 1, 2, 3, 4, 5, 6, this guy right here. So what happens is you flip the 7th bit. So we'll make a little note here. So flip the 7th bit, right? So when we flip the 7th bit, we end up with 0, 0, 0, 0, 0, 0, 1, 0. And if you're looking ahead at the link local address, seeing that it's in that octet or the hextet there, it's 224. So what is this guy? This hexadecimal character will remain 0. However, this one has now changed, and the value of that hexadecimal character is 2, because the binary is 2, right? This is the binary position for the value, the bit value 2. And so now we convert it back to hexadecimal, and decimal 2 would convert, you go from binary to decimal, you get 2, and hex, from decimal to hex, the value is still 2. So now we get this new MAC address, which is 02 colon 24 colon 97 colon 27 colon Charlie 4 colon 3 alpha. So we end up with a new MAC address, right? So this is step number 1, right? We write that MAC address out, and then we convert the 7th bit, we flip it, and that gives us a new MAC address. And then from here, it's extremely straightforward. So step number 2 is you take FF, FE, and you insert it in the middle of the MAC address. So we're going to insert, whoops, pin stop there. Let me go back a second. So we're going to insert FF colon FE into the middle. So now the MAC address would be 02 colon 24 colon 97 colon FF colon FE colon 27 colon Charlie 4 colon 3A. Now, if you look at this, you'll notice that we've gone from 48 bits, we've added in 8 additional bits here and 8 additional bits here. So we've gone from 48 to 52 to 60, right? But we're still well short of what we're looking for. So, and again, this is step 2, is to add in the FFFE. The final step, as you can imagine, if you look at the address right here, you can clearly see that we need to add in the FE80 at the front end and then put it into IPv6 form. So we have FE80 colon colon, and now this would end up getting written in IPv6 form. And so we've got 1 hextet, we're going to have, whoops, 2 hextets, 3 hextets, and 4 hextets. So 0224 colon 97 FF colon FE 27 colon Charlie 4 3 alpha, right? And so we know that if the address is 128 bits for an IPv6 address, we've got 16 bits here, 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 and here. How many do we have that are represented in here? So 1, 2, 3, 4, 5. 16 times 5 is 80. So we're missing 48 bits here, and really all those are, it's the rule of zeros, right? So if we're missing 48 bits, we're missing 3 sets of the quad zeros, right? So to write this out, fully write this out, it'd be FE80 colon 0000 colon 0000 colon 0000 colon and then 0224 and so on. However, we can collapse things down, and in fact, you'll notice that the leading 0 is also dropped in our LinkLocal address. All right? So, and it's important to understand where those addresses come from, because sometimes you'll find administrators will just simply throw the global unicast address on there, not really paying attention to the LinkLocal address, and so it's a good thing to know how to calculate that. So, you might say to yourself, well, Travis, this was probably a little easy. You've got the answer right here in front of you. And so we're on router 6 right now. If I were to go back over to router 5, right? And router 5 has a serial link and then FA00. So if I do a show IPv6 interface brief, you can see that we're not using FA01. So I've switched routers, and let's take a look at show interface FA01. All right, so here is my burned in address. So let's go ahead and see if we can accurately calculate using the EUI64 method what that LinkLocal address is going to configure itself to auto-magically. Whoops, EUI64. What that address will configure itself to auto-magically when we enable a global unicast address on there. So again, it's very straightforward. So we're going to write the MAC address down. So it's 00 colon 1F colon 6 Charlie colon Fox 0, and I guess I'll put lines through here to make sure we got that. Fox 0 colon Charlie 8 colon and Alpha Baker. All right, so there are my 48 bits for my MAC address. So I got to find the 7th bit. Again, very simple here, right? We've got all zeros, so this will be very straightforward. So this is in binary, 2, 3, 4. So in binary, each of these zeros, and this guy here comes to this one here, represents 4 binary zeros, right? So where's my 7th bit? It's that bit right there. It's this bit right here. So we're going to flip it to a 1. And now the MAC address, so we flip it to a 1 in this binary position. It gives it a decimal value of 2, which also will convert right back in hex to a value of 2. So here, the new MAC address is 02 colon, 1 Fox colon, 6 Charlie colon, Fox 0, those lines through there, colon, Charlie 8, colon, Alpha Baker, right? And so this is my, remember, this is sort of step number 1, is make that conversion of your MAC by flipping the 7th bit. All right, now that we've done that, the next thing we're going to do is we're going to add in the FFFE into the middle. So then the MAC address would be, and so we'll put a little note here, FF colon FFFE. So let's add that in. This is step number 2. So our MAC now becomes 02 colon 1 Fox colon Baker, or I'm sorry, it's a 6. 6 Charlie colon FF colon FE colon, and then it's going to be Fox 0, and I am running out of space, Charlie 8 colon, and off to the side we'll do AB. So again, we've added FFFE into the middle of the address, and then the final step is going to be to add in at the beginning of the address FE80, and remember we know that there are 1, 2, 3, 4, and then 1, 2, 3, 4. There are 48 bits of zeros here, right? And then we have 1, 2, 3, 4 hextets. So this would become 02 1 Fox colon, and that's a 6. 6 Charlie Fox Fox. Get a better C there. 6 Charlie Fox Fox colon Fox Echo Fox 0 colon Charlie 8 Alpha Baker. All right, I want to put lines through all those zeros there. What we can do again is the rule of zeros, right? Or the IPv6 rules for zeros. We can drop leading zeros and we can collapse multiple occurrences of the quad zeros. So if we were to write this out in condensed format, we end up with FE80 colon, and we're going to drop that, drop that, drop that, and we're going to drop that leading zero there. 21 Fox, I'll do it in all caps here. 21 Fox colon 6 Charlie Fox Fox colon Fox Echo Fox 0 colon Charlie 8 Alpha Baker. So again, that's the process for, this is the process for the EUI64. So let's check it. Let's see if that's accurate. How would we do that? So I'm on router 5. I'm going to go from privilege exec into global config. I'm going to go into interface FA01. I'm going to say no shut. And we're going to go ahead and assign it an IP address, IPv6 address. So IPv6 address, and we'll just make it 2001 colon DB8 colon FEED colon 55 colon 5/64. All right, so now we do the do show IPv6 interface brief, and let's see if our guess at the address, which is FA01 FE80 colon 21 Fox colon 6 Charlie Fox 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 Echo Fox 0 Charlie 8 Alpha Baker. All right, so there it is. And again, very straightforward process. You convert the hex into binary, you flip the 7th bit, you then convert that to decimal, and then back into hexadecimal. And typically you're going to find that this value is usually 0. So when you flip it, you know it's going to end up as a 2. So then you rewrite your MAC address out. You then add FFFE into the middle of that MAC address, and then you precede it with the LinkLocal, the leading 64 bits from the LinkLocal address, the 16 bits here in that hextet, and then the 3 quad zeros and those 3 hextets for a total of 64 bits or 4 hextets, right? And that's kind of your prefix there for the LinkLocal address. And then you drop in the MAC address into the new form. You use your rules of 0 to condense the IPv6 address, and then that will give you your LinkLocal address. And again, much easier, as you can see, much easier to just simply manually configure it as FE80 : and then maybe match your router number. All right, so let's bring this guy back up here. So hopefully you've got a good understanding as to how the LinkLocal address is randomly selected, as well as how we manually configure that address. All right, so where did we leave off here? Let's do a do show IPv6 interface brief. And so you can see we've done FA00 between... Oh, right. So where we left off was I did not manually configure FA00, which is what we're going to do right now. So let's say IPv6 address FE80 : 6 LinkLocal, right? So now if I do a do show IPv6 interface brief, you can see that now it's FE80 : 6. It makes a little more sense, right? A little easier to look at that address. All right, and so now let's configure we did the fast Ethernet 01. All right, so we should have connectivity up between all of the interfaces here, and that has been correctly configured, and back over to router 4. All right, so we'll come back up here to router 4, and this is where we're going to start the OSPFv3. So OSPFv3 is for IPv6, and IPv6 is a little different than the IPv4 setup, and we're going to see that now. So let's get into global config mode. So I'm going to type in IPv6 and the question mark, and remember we used to type in IP OSP, or for the to start the process was IP OSPF and then the process ID. So if I typed in IPv6 router and a question mark, you can see that I can type in OSPF here, and this is how you configure the global process, right? Now, what's interesting is when we get into the global process, we'll do the same thing we did with IPv4. So the process ID will be 4. Again, that's a locally significant number. When I do the question mark, you can see we've got quite a few options to choose from, and here is our old friend telling us that the IPv3 or the OSPFv3 process could not pick a router ID. So why is that? If you remember from the first OSPF video that we did with OSPFv2, which is for IPv4 and IPv4 only, that the router ID is 32 bits. And during that video we said that even with IPv6, it's 32 bits. So it's still, the router ID is still a 32-bit value that's written out like an IP address, right, with 4 octets. And so the process has been unable to start because we have not assigned any IPv4 addresses to any interfaces. Remember, all of our interfaces at this point, if I do a do show IP interface brief, you can see that we have nothing assigned in terms of IPv4. If I do a show IPv6 interface brief, you can see that we've assigned IPv6 addresses here. And so once again, the router ID selection process, it looks to see if the router ID has been manually configured right here under the router configuration mode for OSPF. If it hasn't, it's going to go out and it's going to look to see, is there an IPv4 loopback address on this router? If not, it then looks for the highest IPv4 interface that's addressed with IPv4 address interface that is not in a down state. And so again, we don't have that here, so let's go ahead and set up our router ID. We'll do the same thing we did last time. 4.4.4.4. All right, so if I do show IPv6 OSPF database, you can see that we see now it says OSPFv3 router, right? And there is our router ID and our process ID number. So what did we do last time with IPv4? We would typically go right to a network statement and put a network in there. But what you're going to notice is network is not even a command. So as we come down here, you can see that network is not even an option for us to pick from. And that's because with OSPF v3, when you're using OSPF v3 and IPv6, you need to remember that one of the major differences between OSPF v2 with IPv4 and OSPF v3 with IPv6 is that there is no network statement with OSPF v3. The only way to turn on OSPF v3 is on the interface, right? Is on the interface that you want it to run on. So we're on router 4. Let's go to interface FA00. And so if I say IPv6, let's see the choices that we have here. So there is an OSPF to pick from, right? So IP OSPF, and it's asking for the process ID, and I have to match the process ID I configured before because that's where we have our router ID. So I would say IPv6 OSPF4, and then what area? Area 0, right? So I'm going to go ahead and start OSPF up here, and let's do this again. Let's do a do debug IPv6 OSPF hello. So now again, remember, we keep adding in, and it's easy to forget, but instead of debug IP OSPF hello, we're talking about debug IPv6 OSPF hello, which we should be seeing right around every 10 seconds. And so, and that looks pretty close, right? So pretty close to 10 seconds, a little skew in the milliseconds column, but for the most part, that is every 10 seconds we're going to get a hello message. And so what does it say? So on FA00, we're sending a hello to FF02::5. Now, if you remember, when we were doing the IPv4, where did it send it to? It sent it to 224.0.0.5. And this was a multicast address, right? And that's where it would send to sort of the all routers, all the OSPF speaking routers. So with IPv6, it's FF02::5, and this is where OSPF sends its multicast out so that it can try to find other speakers at the other end of the link. Okay, so we can see that it's going out. It says area 0, and it says from FE80::4 interface ID 2. All right, so the hellos are going out on router 4. Let's go ahead and configure. I'm going to stop this debugging here for a second. Let's go ahead and configure the serial 010 serial 010 interface, and we're going to do the same thing that we just did a minute ago. So it's IPv6 OSPF, the process ID, and then the area. All right, and so now I'm going to kick that debug back off again because we want to make sure we see the debug messages that are being sent out, because, or the debug messages that are indicating the hellos that are getting sent out, because now you can see for the fast Ethernet 00 and the serial 010 that our packets are getting sent out, right? So every 10 seconds the hellos go out. We'll come over here to router number 5, And let's go from privilege exec into, I'm sorry, user exec to privilege exec into global config. And we're going to do the same thing we did earlier. So IPv6 OSPF, and then, oh, whoops, I apologize. IPv6 router OSPF, and then our process ID. And so here, we're just going to use process ID 5 for router 5. But what's our problem? We never enabled IPv6 routing. So again, we're going to say IPv6 unicast routing. And now let's run that command again. And it works, but we should see, and there it is, again, no IPv4 addresses exist. We don't have the router ID defined, and there are no loopback interfaces. So it says, please configure manually. And it's interesting that it says, please configure manually. I can't remember if it said that on router 4, but again, router 4 is using a different version of code. All right, so let's go ahead and set that up. The router ID on router 5 is just simply going to be quad 5s. And then we want to go into serial 010, and we're going to type in the IPv6 OSPF, process ID is 5, area 0, and we've started OSPF, so we should see some activity here on this point-to-point link. And as you can see, for process ID, the adjacency change went from loading to full. So now, back on router 5, if I were to type in do show IPv6 OSPF neighbors, you can see that we have the router ID here for neighbor 4. The priority is 1. So now, did it select a DR/BDR on this point-to-point link? It did not. However, with IPv6, this default value is 1. And so, again, we're at full state. The dead time, that should not drop below 30 seconds because every 10 seconds we're getting hellos. The interface ID is 5, and this is the serial interface on which I've learned about that neighbor. All right. So if I were to type in do show IPv6 OSPF, IPv6 OSPF interface, we're going to get some information here. It's going to show me my LinkLocal address, shows what area, the process ID, my router ID, and the network type is point-to-point, and the cost is still 64. So the cost remains the same. You can see my hello and dead timers remain the same, right? And my adjacent neighbors, who am I adjacent with? 4.4.4. So let's go ahead and go into FA00. Let's do the same thing. So IPv6 OSPF5 area 0. But we haven't done anything on router 6 yet, so we would expect to see something here on router 6 when we bring that interface up. So we'll say end, and we'll save our config here. And back on router 4, which is going crazy with the hellos. So we'll stop the debugging there for that. However, I want to do so debug IPv6 OSPF adjacency. So we want to see the adjacency activity here when we do configure router 6. So we'll go from privilege exec, so I keep saying privilege exec, from user exec into privilege exec, and then into global config. And let's do this. I'm going to go ahead and I'm just going to create a loopback address. And we're going to say this is going to be loopback 66. And I'll make it IP address 66, 66, 66, 66. All right, so if I do a do show IP interface brief, you can see we've got our loopback interface for route 66, or just for loopback 66, a little Depeche Mode reference there. But 66.66.66. So let's see if after I enable, if I enable IPv6, and I'm in the configuration mode, which I need to get out of, IPv6 unicast routing, let's see if we get that same error message now when I go to start up IPv6 router OSPF 6. Do we get the error? We do not. So what if I do a do show IPv6 OSPF database? What would you expect the router ID to be? And there's your proof that it will actually grab an IPv4 address on a loopback interface to use. However, we know we don't want to do that. So we're going to change the router ID. And as you can see there, the router ID is updated for us. Again, no network statement here, right? We have to go under the interfaces. So first I'm going to go to interface FA00, and we'll say IPv6 OSPF process ID 6 area 0. And so now we should see an adjacency with our neighbor router 5. And so that's taken place. And let's go ahead and go into interface FA01, and we're going to run that same command, IPv6 OSPF6 area 0. We should see an adjacency established with router 4. And so over here, you can see that we still have the DR-BDR election that takes place. Again, the BDR is elected first. And you can see that since router 4 was already up and operational, it had elected itself as the DR. And so when this link came up, the DR cannot be preempted, right? So the DR is going to remain router 4 until something happens to router 4, at which point router 6 will take over as the DR, and then router 4 would come back up on this multi-access segment anyway, and it would become the BDR because there's only these two routers that are there. All right, so if I do a do show IPv6 route, what do we see? So we see similar information when we do the do show IP route. However, here, everything is going to be in the IPv6 form, right? And you can also see that we're learning from OSPF. It's talking about the link local addresses, right? And that's how OSPF establishes the adjacencies. It's leveraging those link local addresses. You can see here the administrative distance, it's still OSPF, right? Even though it's OSPFv3, it is still OSPF. Our administrative distance is 110, and you can see it's calculating the cost, right? The metric OSPF uses to make its routing decisions. It's still calculating it the same way that it did when we looked at IPv4. Okay, so we've looked at setting up the interfaces on the routers with IPv6. We've looked at the configuration of OSPFv3, how there is no network statement. We've brought up the neighbor adjacencies. We've seen that the BDR is elected first and then the DR is elected on multi-access segments. We've seen again that on the point-to-point link, there is no DR-BDR election. However, we noticed that on the point-to-point link, if I do the do show IPv6 OSPF neighbors, so here it shows that our priority is 0. Let's see if over here on router 5, if it's the same thing. Show IPv6 OSPF neighbor. And over here, it still shows the priority as 1, right? Even though it's a serial point-to-point link. Over here, it sees router 5's as 0. Let me pause real quick. All right, I apologize for the small break there. We've got some family calling to say Happy Thanksgiving. And so let's go ahead and let's wrap up this video here. We had talked about some of the things we covered. Again, just to reiterate, there is no network command with OSPFv3. When you use an IPv6, you can only enable it on the interface, and we saw that. And then one of the final commands that we want to run here is going to be the show IPv6 OSPF interface brief, and then this is going to give you a nice overview of the relationships that you've got, right? The neighborships that have been or the interfaces out which you're speaking OSPF and who you're speaking it to. So you can see here the process ID is going to be 4 because this is what we're using here on router 4. Both of these interfaces are in area 0. The cost of the link on the serial interface is 64. On the fast Ethernet interface, it's still 1. and it shows you the state, right? Point to point or DR. Now I'm interested to see what the state shows here on router 5. So if we run that same command, show IPv6, OSPF interface brief, you can see that it does show that it's point to point, and then it shows you the neighbors. So again, OSPFv3 is a little different than OSPFv2 for IPv4. However, you should feel confident enough right now to be able to go through and do the configurations and to get OSPFv3 up and running on your router, and make sure that you always start off, if you're going to be using IPv6 on your router, make sure that you issue the IPv6 Unicast routing command, right? And if I were to do show run and include Unicast, you can see that that command is there now, right? So that IPv6 Unicast routing, that enables IPv6 routing on the router. We also talked about how LinkLocal addresses with the EUI64 are actually automatically calculated, and we walked through one where we had the answer, and then we walked through another one here where we did not have the answer, just to confirm that the process that we were using, the steps we were using, were accurate. All right, so this wraps up the IPv6 or the OSPFv3 supplement, and hopefully you've got a much better understanding as to how OSPFv3 functions, how it works, and that's it. All right, well, have a happy Thanksgiving and a great evening.